Hello, here is Manfred, and last time we implemented the game of life in Clojure using test-driven development, and I already said that I wanted to do a visualization using Quil, and so this is what we're doing today, or basically I have done it already, and I want to show just some examples of how this looks, and then we can go briefly through the code and see how Quil works. And yeah, so I'm not a Quil expert, but and I've taken the example on the Quil webpage, which implements there's already an example which implements the game of life, but so I've taken this example and adapted it a little bit to work with the implementation we have done last time, right? So let's get started. Let's show some yeah. Let's take some game of life special characters like the blinker and the toad here and the glider. So I have created grids for those three basically, right? And I want to run them using Quil. Let's do this. So this is our first one. This is the blinker, right? If you go to the Wikipedia page of Game of Life, you will see that you will also see the blinker there. Then let's switch the blinker off and switch the toad on. Save the file, run line, run the program again, and then we have two things here. We have the toad, which is also basically a character, a game of life character, right? A special character. And as a last one, let's do the glider. The glider will eventually walk out of the screen. So so I have to be quick a little bit to run it. Did I save here? Save, yep. Line run. Let's pull out the other two, and then we will see the glider. So you will see that it walks slowly down right until it can't go any further. And yeah, so those three characters. Basically I could do more grids here, so and also larger grids. Those are basically starting grids. And what we've implemented last time is taking the start grid and calculate the next generation. And the thing about those three is, for example, or let's take those two here at the top, the blinker and the toad, and they have such a specialized form that they don't disappear. So they just change their form, and that's it. Okay, so yeah, let's close those and let's have a look at the implementation. So those are our, well, basically we have this is our requirement Quil core. Then we use the Quil middleware. We see later what we use of the middleware. And this is the implementation we have done in the last video. Those are our starting grids, both for the blinker, the toad and the glider. And so this is basically when it's compiled, you have to have a main function, which is the starting point of the application. So this is here. So line run will basically call this function here, and what it does, it runs this sketch, GOF. This sketch is defined here. So this is already Quil. You define a sketch using this function. You set up a size of the window. If you have some setup, you can define it here. The setup is basically this here. So here we define that we want to have a frame rate of 2 per second. So we change the state twice per second. Then we want a color mode, and no stroke means that when we paint something, when we paint a rectangle, for example, that we only want it to be filled, but we don't want a border around it. And this is our state, right? So this middleware here. Let's back up. So we have our setup. Then for every new frame that is generated, and we have 2 frames per second that we have defined here. So for every frame, the update method is called update state. Update state is here. So what does it do? It associates our state, which is this one, which is a map, and it knows a a key grid with a 2-dimensional vector, which is our grid, right? So this ASOC function basically replaces the starting grid with the next generation of the grid. And here we use the implementation we have done in the last video, game next gen. So we pass in the current grid, the starting grid, and it will calculate the next generation grid. And so we have some state here, right? And yeah, maybe there's a way to do this without state, right? So if you know how to do it without state, write it in the comments. And this one here is also called for each frame, the draw method, and we have to find it to be draw state. So it's this one here. It takes the state and it has a background. Those are print functions where I just wanted to verify here on the, you can see it here on the right side, those are the print statements where I just wanted to verify that things are going right. So here here in this let we define the grid size. We just take the number of rows because it's a quadratic field, and if it has 5 rows, it also has 5 columns, right? So we just calculate the grid size, then we calculate the cell size. It depends on the width of the window divided by the grid, the grid size, and we need this later for drawing those rectangles. Then dosec basically is a loop, and it goes and it loops over our grid, And since we have a two-dimensional vector in our grid, we have to flatten it to make it one-dimensional. And then we create an index over this vector, and this index is used as a loop counter, basically, right? So we have our loop counter for each loop, and we have our cell for each loop, and then we calculate a multiplier which takes the loop counter and the grid size, and this is basically to define which where's the place that I have to draw something now, right? And then we define x and y coordinates, and this Quil fill function basically defines the fill color. And the fill color depends on whether a cell lives or a cell is dead. So if a cell lives, I want to have a color of 0, which is black. If a cell is dead, it has a color of white, right? And then we finally draw our rectangle, and I count 1 pixel to the x and y coordinates, and I decrement the cell size or the width and height by 1, because I want to see the borders to the next cell. Yeah, and this is basically it. So what is this middleware here for? The middleware fun mode basically helps us to create our state. So if we wouldn't use the middleware, we wouldn't have a state. All those functions here, update, state, and draw state, they wouldn't have this state parameter, right? And but that's what we need in order, because we have a previous version of the grid, and we need a new version of the grid, and the new version of the grid is calculated on the last version of the grid. So we have to have some state. So again, if you know how this works without state, please write it in the comments. Yeah, and that's basically it, right? So thanks for watching. Goodbye.